Okay, so let's take a look at this Bayes Theorem question here. All right, so in Tulsa, 70% of the residents contracted COVID-19. So what I'm going to do is I'm going to come over to my spreadsheet here, and in one column, I'm going to put contracted COVID, and I'm just going to make that COVID. And in the other column, I'm going to make that no COVID. So these are the people in this column, this variable, or these are the count for people who had COVID. This column counts people who did not have COVID. It says approximately 15% of the residents with COVID-19 got a false negative COVID-19 test result indicating that they did not have COVID-19 when they actually did have the disease. So we have also not only the reality of people having COVID or not having COVID, we also have positive tests and negative tests. So this is test positive for COVID. I'll just put positive tests. And this is test negative for COVID, so I'll put negative test. So we have two situations, the reality of the situation, whether or not the person has COVID. Those are in the columns. And then we have the testing situation, whether they tested positive or tested negative. I will also put totals here. So this will give me column totals, and over here I'll find my row totals. For instance, it says 70% of the residents contracted COVID-19. What I'm going to do, since they didn't tell me how many residents, I'm just going to assume that there's 100 total residents to make things easy. Out of 100 residents, if 70% of them contracted COVID-19, I would expect 70, which is 70% out of 100, to have contracted COVID-19. And then the rest of them, which out of 100 would be 30, because 100 minus 70 is 30, would not have gotten COVID. So those are my marginals. That's the marginal for the COVID, that's the marginal for no COVID. All right, so first of all, it says that 15% of the residents with COVID-19, so I'm talking about these 70 people here, 15% of those 70 people who actually had COVID-19 got false negative COVID-19 results. So 15% of 70 actually got a negative test result even though they had COVID. That's a false negative. The test said negative when the person actually had COVID. So what I'm going to do here is I'm going to type equals 0.15, which is 15%, times of the 70 people. So 15% times 70 people, that's this many people who got false negatives. They had COVID, but the test was negative. Now, the rest of the 70 people actually tested positive. That's a correct test. So how many is that? Well, that's equal to 70 minus this many, 10.5. So that's 59.5 people. So the 59.5 plus the 10.5 would give a total of 70. So, all right, that's the total number of people, 59.5, that tested positive and actually had COVID. All right, now it says here that similarly, 7% of the residents who did not have COVID-19, so I'm talking about these 30 people that did not have COVID-19, got a false positive result. So that means they tested positive to say they had COVID, but they didn't actually have COVID. That's 7% of these 30 people. 7%, which is 0.07. 7% of 30, which is 0.07 times 30. So that's 7% of the 30 people, which is just 2.1 people, got false positive results. That means the rest of them got real positive results. They didn't have COVID, and the test said they didn't. And that's the 30 that tested, or the 30 that didn't have COVID, minus the 2.1 that actually tested positive. 30 minus 2.1 is 27.9. If you add those two up, it equals 30. All right, so I have my joint numbers inside of here. These are actually joint probabilities since it's actually out of 100. These are joint probabilities as percentages though. Over here I'm going to have my totals for the positive tests and the total for the negative tests. So that'll give me the probability that somebody tested positive and the probability that somebody tested negative. So the probability that somebody tested positive is equal to this 59.5 plus this 2.1. 61.6 people tested positive out of the 100. And then here, this is equal to, well, is that sum B3 plus C3, so I'll just press enter. That's 38.4 people tested negative. So of all the 100 people, I had 61.6 positive tests and 38.4 negative tests, while I had 70 people with COVID and 30 people without COVID. All right, now let's see. What is this asking? This is a Bayes problem. We're just doing it with a contingency table instead of the formula here. So let's see. It says here, if a Tulsa resident is randomly selected and their COVID-19 test came back positive, what is the probability that the patient actually had COVID-19? That would be asking what is the probability that the person had COVID-19 given that we already know that their test came back positive. So given a positive test, what's the probability that somebody had COVID-19? So that means we're restricting it to only the people who had positive tests. The people who had positive tests were these 61.6 people. Out of those 61.6 people, we're going to look at the fraction of those who actually had COVID. The number from the 61.6 that tested positive, given that they had COVID, would just be this 59.5 out of that 61.6. So I'm just going to do it one time. This is equal to this divided by this. There we go. All right, so that's 96 or 0.9659. Let's round it to 4 decimal places. So let's round it to 0.9659 or 96.59%. So 0.9659, and let's see. There you go. That's how you do a Bayes problem